we need to be talking about this from health and from air quality and from toxicity and from resiliency and from durability. And then you throw in like, oh yeah, and it's more energy efficient to boot. It's, game, set, and match, right? There's no arguments at that point. They can put you in a house that is measurably healthier for you and your family, right? Those are things that attract people. And yeah, I think it's growing. Like, people are becoming more and more aware of the fact that there are better ways to build than maybe what we're used to.
Hello and welcome to the Reimagine Edit, a special series of the Passive House podcast that shares curated insights from the conversations happening in the Reimagine Buildings Collective, our membership community where we bring together climate-conscious builders, designers, and change makers to share lessons, level up our work, and build the networks we need to thrive. In this episode 12, we'll hear from Ben Bogie, Jake Bruton, Michael Ingui, Ed May, Kristof Irwin, and Ashley Wisse. I'm Zack Semke, Director of Passive House Accelerator and host of the Reimagine Buildings Collective, and thanks for joining me. First up, we hear from Jake Bruton. You may know Jake from his appearances on The Build Show, as a co-host of the Unbuild It podcast, or through his writing for the Journal of Light Construction and Fine Home Building. He's a custom home builder based in Missouri, and in this clip from his Reimagine Construction interview in the Reimagine Buildings Collective, Jake fields a question from Scott, a collective member, about how to communicate with clients about passive house and cost. You'll also hear Michael near the end of the clip.
I'm kind of new to the whole passive house world, and cost always jumps up. So how much of a barrier does this 5% or less than 5% premium end up being, and how do you address that with your customers, and how do those conversations go? Because I'm already not gun shy, but just like, oh geez, another budget thing that's sort of largely invisible. It's like paying more for like you have bad soil, paying more for your footings, and nobody gets to see that, or
Sure.
Yeah.
So again, we only talk about things from a this is the right way to do things standpoint. So we never talk about this kind of stuff from a, hey, this is more expensive, you should spend more money on it standpoint. And because we're involved in the pre-planning, and as an architect, you also get to be involved in the pre-planning, obviously, you have the ability to say, this is how much it costs per square foot. If you have the builder on board at the beginning, which I would encourage everybody to try to do, because you need that checks and balances. You need somebody standing there going, yeah, but it's going to cost $500 a square foot or somewhere around there. So we know your budget. So we have to keep the house under this if we're doing all these things. Then we can just say, well, we have to make the house a little bit smaller. You have to give up a little bit of square footage. Well, maybe we're not putting in the sauna in the backyard right now so that we can have European windows, so that we can have triple glazed windows and you can have optimal comfort. Or like for us, we just include a lot of these things in our base pricing, and it's not up for debate, and it never even comes up. Like, we know we're going to have continuous exterior insulation. We know we're going to have triple glazed windows. We don't necessarily include a metal roof, because the metal roof versus an asphalt roof, those things don't have anything to do with health and comfort. And we can talk about that as an option if there's money left over. But we definitely include air sealing to get us to that 0.6 number, because we know that that's where comfort starts. And if we were to build the house to 3, then that makes the mechanicals cost more. It makes health and comfort less likely. It makes callbacks more likely. Like, we look at it as no different than water management. We wouldn't sacrifice water management and put a warranty at risk where, like, yeah, we know we're going to let water in, but we didn't want to spend the money on that. So we look at it exactly like that, and we just don't give it as a choice. We just say, this is our standard, and we hold this standard to make sure that you have health and comfort and efficiency, and we're not putting our warranty at risk. And then people are like, oh, okay.
I like how you tied it back to health and comfort for them.
Yeah, and tying it to warranty and longevity of the building. I think it's obvious once you say it, and super smart. I like it. I might steal a little bit of that, just so you know.
All I'm doing is what's appropriate for your windows, what's appropriate for your wall, what's appropriate for water management. You just know that there are other builders in the market that are willing to cheap out and skimp on that because they're willing to do that. I'm not, because I know what the risk is and what you're going to complain about if I do that.
Next up, we hear from Ben Bogie in a clip from his Reimagine Construction interview with Michael Ingui. Like Jake, Ben is both a builder as well as a thought leader and communicator about high-performance building and building science. You know Ben if you've taken part in the BS and Beer Show, or you've seen his work at Fine Home Building and Green Building Advisor, or taken in his wisdom at one of the many industry events and podcasts that he's appeared on. Here, Michael asks him about his approach to retrofit projects that touch some, but not all, of the building.
Over the summer, we did these cohorts where
Mhm.
each cohort was 6 or 7 people, and we really just dove into a topic, and mine was retrofits. And in our retrofit, one of the other questions we were asking ourselves, or just posing, is the interesting situation when you're only retrofitting really well some of the building, which I can't imagine you're not on houses where you're doing that, because I mean that's the world we're in. Some
Mhm.
for either a budget reason or maybe the buildings. I mean, I've worked on projects where people would kill me if I ripped out half that house.
Mhm.
How do you approach them is really the question.
Retrofits are a tough nut to crack with any sort of broad blanket statement, okay? Because they are so individual in their own characteristics and in the place where they sit and in how they've been put together and how they've been maintained, and all of these things come together in a confluence there to make it particularly difficult, right? It's like I love new construction because it's controllable. We control the whole thing, right?
Yeah.
Uh, and the thing that adds further complexity to all of this is to be able to decide how to approach retrofits, or even just to do the actual carpentry work of remodeling, requires a level of experience and professional knowledge that is increasingly rare in our industry and is disappearing every day. Further difficult, right? These are cultural questions that we need to address as a society on how we think about supplying housing for people and making housing better. But meta level aside, typically I'm going to do the best I can with what I am able to convince them to let me touch, right?
Yeah.
Obviously, like we just did, it was a lovely 1890s colonial where we did a bump out 3-car garage with primary wing over it and some new living space, but we're not touching the existing house, right?
Mhm.
So like how much impact are we really going to have? And it comes down to, do the best with what you can, right? So we're going to do the best with what we can. As far as what we choose to do, that's going to vary. The primary thing, everything else aside, that we have to do first and foremost is manage water. Water, 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 water. Because that is going to be what
Yes.
undoes our work for us. All right.
100%.
What's destroys the buildings. If we can put together a strategy of how we're going to do that for the building, first for the water from the sky and then the water from the ground around the building, once we do that, then that will typically help to inform our strategy of how we're going to do the rest of the retrofit, right? That's going to be that first order principle, is like, how are we going to make sure that this building manages water effectively? Then we move on to what's next. The next question typically gets weighed against floor area availability, right? If we are in a situation where we have a small footprint in an urban setting where we don't want to lose conditioned floor space, then that is going to force us to go to the exterior, right? And there are going to be cost implications to going to the exterior of a building. There might be zoning implications to thickening the exterior walls, right? So that's the next kind of criteria level for me, is understanding where we can steal space from, because we're trying to add more insulation. Fundamentally, that is one of the core principles of the work that we're doing. We're trying to add more insulation in order to control the energy exchange across the assemblies. And that insulation has to fit somewhere. So then the next thing we do after we manage the water is figure out where we can get that insulation to fit. So that's going to be the next kind of level of hierarchy of what my choices are. Then beyond that, once I know that, it's going to kind of dictate where I'm going to go for my air control, right? And it's also going to guide where my vapor control is. And to your comment about understanding vapor and introducing all of that, I think our industry spends way too much time hung up discussing vapor. It's not the boogeyman that we think it is. Sure, it can come and kick you in the ass if you do something stupid, but there's a lot of great information out there on how to not do stupid from places like Building Science Corp, or even aghast, the International Residential Code. If you pay attention to the vapor control and the insulation ratios that they suggest, you're going to end up with assemblies that are safe. Are they the highest performance? That's debatable, but there is good information there. So yeah, water, thermal, where I'm doing the thermal is going to kind of indicate where I'm going to put my air control at that point, and then it kind of all just cascades and you find yourself into an assembly.
Now let's pivot to Ed May and a clip from his recent AMA Friday Ask Me Anything session in the collective. Ed is an expert in residence in the collective, the instructor of 2 of our flagship courses, and a passive house consulting and education powerhouse. Here, collective member Mark Attard asks about the FIAS process for passive building design, particularly the early phases of design and decision making.
I am one of those people that have been in the PHI world for a while, and I am making forays into the FIAS world. And I was just curious, there's a few different differences between the two, but just in terms of the general process, I'm just kind of trying to get the lay of the land and understand what those differences are. The way that I work right now, I'm going to use a design pH, and I'm going to build out some data from that to talk with my client.
Sure.
Do I start in FIAS with a Wolfie, or do I start with something else? Because it seems there's a couple of different ways in with FIAS.
So boy, it's a good question. Yeah, so we do both. PHI and FIAS, we like them both. We use them in different places. There's definitely some important differences, and the workflows are definitely a little bit different. So from a high level, if you're coming from the Passive House Institute or the international system world, you're absolutely right. There's a few different methods of certifying to FIAS, and there's a few different levels of performance. So number one, there's what we might call a performance and a prescriptive path. So, you might be familiar with that kind of lingo from like the building code. Basically, there's like a version where you do a detailed energy model, and then there's a version where you have a checklist. And so that's like a fundamental kind of like split, like right out of the gate, you do one or the other. My understanding is that the intent behind the checklist is that it's supposed to be easier to execute. So there is no requirement for modeling. You can't do all the thermal bridging assessment and blah, blah, blah. So it's an easier sort of process to move through, much simpler, faster, cheaper, smoother. But because you don't have an experienced practitioner or a professional who's kind of looking over your shoulder the whole time, the requirements are more stringent. So maybe like in structural terms, you might say like the safety factor is sort of smaller or bigger. I don't know. It's more stringent. The requirements are kind of more onerous because you don't have somebody applying judgment along the way. You're sort of just complying with the checklist. So you end up with like thicker walls, more insulation, more sort of by the book thermal bridges or junction details, without any of the wiggle room when you go down the model route. So there's pluses and minuses to all of that, of course, and there's different cases where it might be applicable. But that's the sort of initial break, and then once you get a little further, you'll see that there are actually different levels of performance. So you can certify to either what they call a core certification, or a 0 certification, and the core certification would be kind of analogous to like the classic PHI certification, and then the 0 is a site net zero energy certification. So where you offset all your energy consumption through on-site renewable energy generation. So different levels within there as well. As far as the actual process, like I said, we use both. We like both. They both have their pluses and minuses. I would say probably the one thing about FIAS that we have grown to appreciate is that we find them to be a bit more amenable to US style products. Case in point would be, we're doing a project, a PHI certification project, and we want to use a ThermaTrue a door to the garage. Therma-Tru is a company based in the US, and so they don't have any ISO testing. And so in order to use that product on a PHI project, we're gonna have to create a whole bunch of custom ISO frame profiles and tests, and we have to spend, it's gonna be like a few weeks to kind of like find the right CAD profiles and go through all that process. By contrast, if it was a FIAS project, you could just use the NFRC modeling. And so there's like very important differences when it comes to the ability to use domestic products and the sort of ease with which you can use those within the test protocol. Now, that's not saying anything about like appropriateness or like quality or anything like that. I'm purely talking process. It's just, we find it to be a bit easier, a bit more straightforward when it comes to US windows, US water heaters, US appliances, the kind of stuff that you have in the United States and Canada. We find it a little easier to work through the tool chain there when it comes to FIAS. That said, of course, we still do plenty of PHI and plenty of both. But in terms of the design process that you're talking about there, I would recommend that yes, you probably get started with the WFI model. It is possible to approximate the WFI model within PHPP, but that's probably more trouble than it's worth. I would say probably if you're considering doing FIAS, just jump into that WFI model. There's a bunch of defaults and things that are built in there that are sort of easy to or important to use in the earliest stages to make sure that there's no big red flags or big potential issues or anything like that. If you're using the Honeybee PH toolkit that we've been sort of looking at together, what you'll find there is that you build the model, and then at the very end, you can decide, do I want to send the model to PHPP or do I want to send it to WFI Passive? You can sort of choose one or the other. It's a sort of branch. And so the same model can go to both. But you would typically only use one or the other. You wouldn't use them in combination.
In this next clip, we switch the tables on Michael Ingui from being the interviewer to instead being the featured guest for an AMA Friday Ask Me Anything session in the collective. So let me take a quick moment to introduce Michael a bit more formally. In addition to being the founder of Passive House Accelerator, Michael is co-founder of Source 2050, the multi-vendor marketplace dedicated to high-performance building products. He's also the president of Ingui Architecture, and his work there has distinguished him as an internationally recognized leader in Passive House practice, specializing in retrofits of historic masonry buildings. He's also a close colleague and friend. Here, Silas, a member of the collective, asks Michael about working with Ed May and how Ed's modeling process, which really sings on larger projects, also applies to Michael's smaller residential ones.
Little modeling question for you, I guess. I'm learning to be a CPHC, and I've also been checking out Ed's Honeybee PH course, which is a whole other deep dive. But since you work with him so much, I'm curious for your perspective on the kinds of useful modeling or data he is able to give you through that on the residential scale. Because it sounds like, he sort of says, oh, it's most useful for large scale projects, but they use it for everything. So wonder what your perspective is.
One of the things that I'm most excited about with regards to what Ed and John are doing and what they're working on and what I think they can impart on the community is some of the modeling stuff that they do and the speed at which it can give you answers. And I sometimes forget how spoiled I am. The trajectory of a typical project for me. So for a few things. One, many of my clients don't care about Passive House. They hire me because they want a really beautiful landmark building. And we're really there. We're really a design firm. And I don't do any of my own Passive House work, even though I'm certified and almost everybody else here is certified. We hire people to do it because I like being checked by a third party. Also, we wind up dealing with so many technical issues that I need someone who's like at the top of their game. So we have found a whole bunch of really great people to work with, and John, one of them. My typical process is I will either do an existing edition myself, or we'll bring in a 3D scanning company, which we're doing more and more. And then almost immediately after that, we're asking John and Ed to build a dumbed down Rhino model for us and start to tell us what we're looking at. and it'll tell us almost immediately where I can do my big windows, where I can't do my big windows. If I am going to do a big window, where I've got to do shading, where I should not do my skylight no matter what. And because I've got to deal with landmarks and they've got that sensibility as well, I mean, I know in a day or two, like I know early, I know super early, and I would say only 30% of my projects are certifiable. I mean, we have 7 teams. Each team has 2 or 3 projects, so we work on a few projects. Only 30% of those or so are certifiable. A lot of the others are great houses, but we're not renovating everything. We work on a lot of historic, beautiful restoration projects or other things, and we do all sorts of combinations of things. So having them model a house for us, it's only partially renovated sometimes. That for me is the most difficult house, because some of my house is going to perform really, really well. The rest of my house is going to perform like crap. And I know it. There's nothing I could do about it. And it's beautiful in some cases, like beautiful, like someone put money into restoring that thing. And so having it modeled so I know what I can do in both places. So for example, maybe I'm putting, if I'm keeping radiators, maybe I'm only keeping radiators in a portion, not the other portion. Or I'm making sure I got a manifold so I can separate them and put 2 thermostats in. Or I make sure if it's a Mitsubishi or a Daikin, we're doing lots of LG these days, that I'm making sure I'm separating the thermostats. So there's a lot of things you can do and decide super fast, super early. And honestly, I really do take it for granted sometimes how easy it is to make those decisions. Now, it hasn't always been, but it's only in the last 6 months or a year that we've been able to work with them that way. So the classes that Ed's teaching, I'm really excited about, because that's what he's teaching. He's teaching that program. He's teaching how he does that. And although I think it's really great to do all the certification projects, just knowing those answers super early, I couldn't do Passive House otherwise. I just
So
wouldn't even do it. I wouldn't even start it. It wouldn't bring it up.
yeah, particularly
Wouldn't
useful, you say, in projects that are not full renovations, because you
I
can.
think it's so essential. When I think about all the projects, what I used to do is try to figure it out. And, we work with really experienced HVAC people and plumbers and mechanicals. And we'd all be like trying to figure it out, make sure we had it. And we'd either just do it a little big, or little larger systems, or at least have some extra electric where I might need to do a baseboard radiator later. All the things you used to do that we don't have to do now. It's just so helpful. So the stuff that Ed's teaching is that stuff. And what's cool for me about Ed, and I just think it's really, I mean, more power to him. I mean, the fact that he shares this much so openly is really, really cool.
Next, we hear from Kristof Irwin, lead engineer, co-founder, and principal of Positive Energy in Austin, Texas. Kristof is one of our community's true deep thinkers, so it's always a treat to have him join us in the collective to share his ideas. He's also the host of the excellent Building Science podcast and is active in all sorts of important and influential committees with ASHRAE, ResNet, AIA, FIAS, and more. Here, Brent asked Kristof about using water for cooling, not just heating.
Hey, Kristof, I just listened to your podcast episode from, I guess, a year and a half ago now. I think with the owner of SpacePack, or maybe
He's
someone
one of the
associated with SpacePack.
lead engineer, technical engineer.
Yeah. And so you're talking about Exergy and using water and air-to-water heat pumps, and then you start talking about cooling with water. And maybe I'm like super behind the times, but in my head, water was only for heating. And now we can push water to a fan coil. Is that a typical installation that people are doing in residential retrofits, things like that? Or is that like new and people don't know how to do it?
Okay. So everyone else that had questions, I'm sorry, you're not going to get to them because this is going to take the rest of the hour. No, I'm totally kidding. However, you've just, you've touched in a huge topic. Stepping back one level, what mechanical systems do to provide a high quality indoor experience is they provide heating, cooling. That's thermal comfort. That's what you're asking about. Then they provide filtration, ventilation, humidity control, pressure differential control, right? So we're over here on the heating and cooling side, the thermal comfort side, which is going to tie into, sounds like something Lloyd wants to ask. So in the thermal comfort realm, what we're really doing is we're trying to control like the body's internal temperature. So its homeostatic balance is met. So it says, oh, I'm good. I'm good with this thermal environment. In fact, the 55 standard, the ASHRAE standard says something along the lines of comfort. Thermal comfort is that state of mind, right? That expresses satisfaction with the thermal environment. So that's what I'm trying to give you, Brent. I'm trying to give you that state of mind. And then what I recognize is to cool you, I simply need to absorb heat from you, right? And so one of the first principles that is somehow hidden, it's hidden, but right in plain sight, is that the body's dominant thermal experience of an indoor space is with the relationship to the surrounding surface temperatures, right? So what we do is, let's imagine you're sitting inside an empty spaghetti pot right now. And what I say to myself is, I want to cool Brent off. So that means I want to cool the walls of the spaghetti pot off. So what I do is I fill it with a cool fluid. And that, what we do is we say, oh, I'm in the cool fluid. That's why I'm cool. What we don't understand is, no, I'm in the cool fluid and so are the walls. So the cool fluid is pulling heat off of the walls and taking them somewhere else, taking the heat somewhere else. So radiant heating, let's say the ceiling above you is hot. It's radiating heat to you. Your body's absorbing that heat. It warms you up. Your homeostatic balance is happy. Radiant cooling, exact same thing, but instead of the ceiling being 95 degrees, it could be 65 degrees. Now you're the heat source. You're radiating heat to the ceiling. It's absorbing the heat. You're losing the heat. Your homeostatic balance is met, right? In one case, we call it warmth. In one case, we call it coolth, right? So it's really like from a thermodynamic standpoint and the relationship with human physiology, it's very similar. And we're working with the body. But then it's like where I say, wow, that's why we're not going to talk about anything else right now, because it potentially reduces the amount of refrigerant we use by an order of magnitude. It uses an otherwise, heat pumps leverage an otherwise unusable waste heat in the environment basically as a source of energy, right, for heating. I'll stop there. You want to do a quick follow-up? Yes, please.
So I know about like radiant cooling panels, like in the commercial world, and I guess they would be applicable in residential, but
chilled beams.
Yeah, right. What do we do with the humidity though?
Oh yeah, we control sweating. We insulate the pipes if they're going to be exposed to outside air. But let me just be emphatic about this. There are plenty of other reasons that we want to control indoor humidity and keep it within acceptable ranges, not just to unlock the potential for radiant cooling. And I could start to list those, but health is a huge one, right? The indoor microbiome. It's like Osgo 211, right? If you let it get humid, you turn up what's going on with the indoor microbiome, mold, mildew, archaea, all these things. But yeah, just so I would say, big picture, we're an industry, and industry is our ecosystems. And there is a technology aspect of this industry, and it has tried in the past to introduce air water heat pumps for heating and cooling into the US market. And this is the big Daikin push in the late 90s, early 2000s with their Altherma system. And we didn't pick it up. It was perceived as a pearls before swine kind of moment. And I don't really know that, but that's like the story. And so they pulled out. Well, now it's 20 years later-ish, and we have 4 or 5 very large manufacturers. I mean, I could list some names, but let's just say we've very moving hydronics back into the industry, partly because of the brain damage that the refrigerant transition is going to impose on us. We are going to be ratcheting down global warming potential of refrigerants now through 2047, unless we change the rules. And the R410A to R34 or 454B, R32, excuse me, 454B has not been going perfectly. It's very confusing for installers, very confusing for designers like me. I need information from the manufacturers. It's not out there. All I know is the previous source of information for R410A is no longer valid, but I don't get the new stuff. So it's this sort of chaos. And then if you think about your building, right? Your building should be able to last, many, many decades, even beyond 100 years. Soon as you go radiant heating and cooling, or even just hydronic heating and cooling, keep in mind now they still have ducts, right? Everything's the same. It's just instead of refrigerant lines, you have water lines.
Hydronic. Oh, okay.
Yeah, so hydronic is the thermal fluid. Water with water glycol mixes the thermal fluid. So what we do is we make the house agnostic to refrigerant. There is simply a pipe that needs to receive cool water in the summer and a pipe that needs to receive hot water in the winter. And we don't need to care where it came from, right? Mr. Fusion for cold and hot water. I don't care where it comes from. But this other big thing is, like, I think we all probably know that, I don't know, has anyone ever heard the expression Q is UA delta T? That's an engineering formula, but basically heat going into a space is proportional to the area and the temperature differential. So if I want to heat you now, and the area of the heat exchanger in the heat pump is just this, either a flat coil or an A coil, that's a small area. I need to make it much warmer and move air across it. And then that warm air goes throughout the house and controls the surface temperatures. And that temperature is probably 120 to 150 degrees, something like that. Boilers would be 180, 200 degrees. So as soon as you do, oh, that whole ceiling above me is the area. Now, keep in mind, it's area times delta T that's proportional to the Q, right? And there's the U factor in there. So if the area goes up, the delta T can come down. That's why I said 95 degree ceiling temperature. So I only ask my heat source to go to 95 degrees. What does a heat pump love? It loves to not have to raise its temperature much above the outdoor condition, right? And you have the same benefits in reverse.
Next up, we hear from Ashley Wisse, director at New Ecology, where she manages high-performance design, construction, and renovation of multifamily affordable housing throughout the Northeast of the U.S. Ashley recently presented a Passive House Accelerator live presentation about New York State's first net zero carbon multifamily retrofit. And she joined us in the collective for an AMA Friday Ask Me Anything session to dive deeper with collective members. Here, Karen asks her about the geothermal installation that was part of that project and lessons for single-family applications. Near the end of the clip, we hear from architect and collective member Brandon Pietras, who shares his geothermal advice as well.
Karen, do you have a question?
Yes, I'm actually really curious more about the physical side of the geothermal installation. Like, what issues came up? I imagine you would have had to do some kind of ground or soil testing to make sure you could drill there. And also, I noticed from the little diagrams that you showed online, it looked to me like all of the wells were very close together, whether that was an issue or not, and what kind of challenges there were in installing that. How deep did you go, and what advice might you be able to give when I get questions from single family homeowners about whether or not to put it in their backyard?
Oh dear. So we did have to do test wells, and I do remember there was some issue with there's a lot of shale in upstate New York and some rock ledge. So we did have to go 500 feet deep each. I don't believe the location adjacent to each other was a concern, but it is located probably about 500 feet away from the building, just in the space that we had available. And so providing the line that transitions from the field to the building was also a challenge, because that had to go under a parking lot. So making it safe while we were doing it, because there were people living in both buildings the whole time. And B, making the infrastructure safe underground so that when people were continuously driving on the parking lot, it didn't affect the equipment. And as far as single family homes, oh boy. I feel like at this time, it's generally a cost issue. If they're willing to spend the money, I think it can be a really great way to heat your home. But I would say most people are going to be priced out of that installation cost.
Do you always have to go down 500 feet or that far?
No, that's just dependent on the needs of the building, the soil conditions. You definitely have to talk to a designer, geothermal designer for that.
Thanks.
Thanks, Karen. Brandon, you're up.
Thanks. Just to contribute a tiny bit to the geothermal conversation, we looked into this for one of our Buildings of Excellence projects as well. We also did 500-foot deep wells. I think we had around the same amount, 34 or 35 wells for the project. For like a smaller family home, I think typically what they do is like the pond type configuration where it's looped really low below ground, so only a few feet. But I know as well a big cost impact can be requiring deep drilling permits for wells that are deeper than, I know it's more than 500 feet. I can't remember what the actual cutoff is, but sometimes to get the efficiency you need to go much deeper than 500 feet. And that can be quite expensive, especially if you have bedrock or something you're dealing with.
In our last snippet, we circle back to Jake Bruton. Here, Greg asks Jake about which construction techniques most excite him.
I was just wondering, along the way, what construction techniques have you learned that most excite you, that you think are kind of transformative? And along with that same question, as far as construction techniques, what walls, foundations, roofs, or anything else in between, what materials have you started using? Any new materials that you weren't using necessarily in the beginning when you were started construction work?
Yeah. Sure. I think one of the things that kind of transformed the way that I looked at things was the idea of buying my own blower door. That was something that allowed us to really hone our skills. So when I said we haven't failed a blower door test since 2017 for meeting passive house levels of air leakage, that's because we have our own blower door test and we can fix it before they come to do a blower door test. We actually test 3 times during the build. We test at the first chance we have for an air barrier. So sometimes that's even pre-window install. We use a lot of zip. So we'll just sheet right over our windows before we even cut them out. We'll tape everything. And then we can test. We can have our air barrier on the ceiling and test, or we can install our windows and then test. And then we'll test after mechanicals, and sometimes after mechanicals with insulation. And then we'll do a final test before the rater comes, and we'll be able to have that, and we'll know what the number is. In fact, when they came to do the final HERS rating on my personal house, our HERS rater sent a new guy, and he's been there for a while now because I've lived here for 5 years. But Jerome walked in and he said, "How's it going?" And I said, "Great." And he's like, "So do you have any guesses on what your blower door is going to be?" And I said, "Probably somewhere between like 0.41 and 0.44. And he was like, "Wow, that's pretty gutsy." He's like, "You really think it's going to be that good?" And I was like, "Yeah." And he ran the blower door test and it was 0.43. And he's like, "How the hell did you know it was going to be that good?" And I said, "Because I ran one like 45 minutes before you got here." And he was like, "Oh, okay." So owning our own door and knowing for sure what things are, that knowledge and being able to turn it on, walk around and find leaks, that's been like a transformative thing for us, because air leakage is more important than insulation when it comes to energy efficiency. Like if you leave the window open, eventually the window is going to let outside in and you're going to be living with outdoor conditions inside. So I would say that has been like one of the things that meant the most to me for changing the way we build, for changing the way we look at things. And then when it comes to the techniques and materials, it's all the things that go with that. Be it zip and zip tape, Sega, their products, their membranes and their tapes, and the stuff from Proseco, from Fast Flash to Cat 5, all those air barrier products, figuring out what works best and where. Or I was on Michael's jobs the other day, the Stowe products that he uses on foundations to seal things in that allow you to make transitions. Like there's a lot out there that 15 years ago, we didn't know what most of that was. We didn't use most of it, and we weren't concerned with air leakage.
Well, that's a great place to wrap things up here. I hope these snippets from conversations inside the Reimagine Buildings Collective have piqued your interest. You can dive into the full replays of these sessions, all available inside the collective. And if you're not yet a member of the collective, we'd love to have you join us. You'll get direct access to experts and peers who are on the same journey as you with buildings, resilience, and climate. Learn more at reimaginebuildings.com. Speaking of membership in the collective, a big welcome to our newest members, Levi Tofias, James Bromfield, Meg Bunk, Elena Bresciani, Jackson Lair, Julie Torres Moskovitz, Catherine Hahn, Stephen Magnerone, Minko Hugerkamp, Ryan Adanilian, Christina Greenfield, Mark Smith, and Joshua Munger. Welcome to the collective. With that, thanks for listening to this 12th episode of the Reimagine Edit, a production of the Passive House podcast by Passive House Accelerator. It's a privilege to share these conversations from the Reimagine Buildings Collective. Every time we share what we're learning, and every time we listen deeply, we move a little bit further along in our practice and a little closer to that future we want to build. None of us is doing this alone. We're learning from one another, building together, and finding our footing as we go. So thanks for being part of this ongoing experiment in reimagining what's possible. And if you're not yet part of the collective and you're curious, check it out. We'd love for you to join us. With that, have a great couple of weeks. We'll be back soon with another episode of the Reimagine Edit.